Hello guys, welcome to LeetCode, and in today's video we will discuss LeetCode question 64, that says minimum path sum. So this question is very much important in terms of coding round and interviews point of view, as it is also a part of top 100 questions from LeetCode, and it is one of the fundamental questions of recursion plus dynamic programming. So yeah, make sure you have complete understanding of solving this question, the approach and the coding part here, right? So now let's begin with the question. So here you are given one m cross n grid filled with non-negative numbers, and you need to find a path from a top left to a bottom right such that the sum of all the numbers along the path is minimum. So this question asks to find the minimum sum path from the top left to bottom right, and during the path or during the movement, either you can move down or to the right at any point of time. So if you take a look at the first example, here you are given this as a grid of a size 3 cross 3, and if you take a look, then this path that is highlighted is the minimum sum path. Any other path other than this will take more, will increase the sum. Okay, and we need to minimize it, so this is only the path. Now if you take a look at the second example, let me draw a grid for you. It is 1 2 3 4 5 6. So this is some type of grid you are given. Initially you are at here, so from here you move to here, then here, and then here. So this path, if you take, then that will be the minimum sum path for the given grid, and the sum of this path is 12. So we written 12 as our answer. Got it? So yeah guys, here the thing is that we have choices, right? At any stage, let's say you are and in this type of matrix, you are initially at here and you need to make some decision to reach here. Okay, at each point you have two options, either to move right one step or down one step. Let's say if you are at here, then you have two options, right or down. So at every point there are two options, move right or down. That means you have two choices, and whenever we have choices, we can write a recursive solution. We can write recursive solution. Okay, and also let's say if you are trying to derive how this recursion tree will be formed. See, initially ij would be 0 comma 0, right? Now from here you have only two options, either to move right or to move down. So if you move right, it would be 0 comma 1, and if you move down, it would be 1 comma 0. From here also you have two options, right, down. So if you move towards the right, it would be 0 comma 2, and down would be 1 comma 1. Similarly from here also two options, right and down. So right would be 1 comma 1, down would be 2 comma 0. So yeah, this way you can build the complete recursion tree. At each node you will be getting a two different node, one from right and one from down, and you will do up till you reach this condition where where the right is m minus 1 and down is n minus 1. That means number of rows and number of columns, the last cell. This is the last cell. Okay, correct? So yeah, this is how the complete recursion tree will be formed, where each step you move either towards the right and towards the down. Got it? Now, so based on this, we can easily write a recursive solution. Correct? Recursive solution with a base condition that if you have reached this, then we will end. This is our stopping condition or terminating condition. If we have reached towards to the answer, then we will stop our calculation. Got it? So yeah, this is the recursive code. See, currently just forget about this thing, just forget about this. Okay, and like just leave these lines and focus on other code. So the remaining code here is nothing but a recursive solution. See, we call this solve function by passing the grid, the ith and the jth pointer. So initially our position is 0 comma 0, right? Then we check for this condition, that whether we are moving out of bounds or not. So if we are moving out of bounds, I return some maximum number. Correct? Then we check for terminating condition, that if we reach towards to the n cell, that is I equals to m minus 1 and j equals to n minus 1, then we return just the value of that cell. Got it? And if this is not the case, not this case and neither this case, then we check for right and down. So this is where we call this function recursively. See what is right, if you want to move towards the right, it is nothing but uh, the value of the current cell plus the value of the remaining path. So this will give us the value of the remaining path recursively, and same for down. Only difference is we are moving towards the right, and here we are moving towards the down, correct? And at the end we will return what is minimum of right and down. Okay, got it. See, from the first cell itself, either we move towards the right and down, and we have to return the minimum of right and down from the first cell itself. And the same thing we have to do for all the cells, return the minimum of right and down. And that same thing we are doing here. Okay, so if you write this much of recursive code, then also it is valid, but it will give you time limit exceeded error, because there are many. Because see guys, see this path, see this 1 comma 1 is repeated here, the same subtree is repeated here, then this complete subtree would be calculated again here, and that is simply but a waste of your time, right? Waste of the processing. So in order to tackle this type of situation where we won't calculate again for the same node or for the same subtree, and for that what we will do, we will simply use dynamic programming, we will simply use memorization. So for that I initialize a dynamic programming array, 2D array of size 201 201. This is based on the biggest size of a matrix. Then first I think I did is we stored -1 into the complete db by using this memory set function, and then during the function I check for whether the cell is already calculated or not. See, if it is already calculated, then its value will be other than -1, right? We initially stored -1, but if it is already there, if there is some value other than -1, then we simply return that value, correct? Because we have already calculated the optimized value from that cell I and j, so we directly return this value. And if that is not the case, then we do recursive. We move forward, do a right recursion, down recursion, and check for minimum of right and down, and then store to dp of ij, ij, that is the minimized value or the optimal value at the current cell I and j. So this is how we will proceed by using memorization, so that we don't calculate for a similar subtrees. Now guys, talking about the time and space complexity. See, for the recursive solution, the time complexity was big O of 2 to the power n. Why 2? Because at every step we have two subtrees, right? Two subtrees or two choices, right? So 2 to the power n. And space complexity was big O of 1. Like I know that this recursion, the stack, memory stack is used for the recursion, but if you look at the data structure, we are not storing anything, so by that way space complexity is big O of 1. Now for the memories approach, the time complexity reduces to big O of n square. Okay, see, one way to look how big O of n square only. See, what is the size of the dp? This size is big O of n square, right? And we are simply storing all the values to big O to this dp, and if any value is already stored, then we don't do anything, correct? So yeah, this is one way to see or to calculate what is the time complexity of memorization approach. We are simply filling up the values of this dp, and the size of this dp is what? Size of this dp is big O of n square, and that's why the time complexity here is also big O of n square. We are simply filling all this much of values, correct? So yeah, this would be the time and space complexity of both the approach. So yeah, that's all for this video. If you guys have any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.